All right, our next unit is basically on identifying functions. Uh, Pretty short unit. We'll take a test for it Friday. So- All right, so to start with, we are going to think of a function like a soda machine. The difference is we're going to go ahead and pretend it's a free one, okay? So the way it would basically work, you should push a button, soda comes out, right? So we won't worry about the money aspect of it. But what we get, when it's working correctly, whatever button we push, we should get the corresponding soda, the one that goes with it. Sometimes, though, you might get something that's like this. Something might not be working right with the vending machine. And you push a button and something different comes out. So, kind of what would that mean for a soda machine? It's broken, not working correctly, someone loaded it wrong, right? Things like that. For a function, they have an input and an output. For a soda machine, they also have an input and an output. For the soda machine, the input is you pushing the button. The output will be the soda. For a function, our input is the x value. The output is the y value. Think of it as if you have an equation, you plug in a number for x, and it's going to give you a y value. For every input, there should only be one. Push the button for Dr. Pepper, we should only get Dr. Pepper, right? If we push a button for Dr. Pepper and we get water or we get tea or whatever, it doesn't work, right? Look at this table here. We've got X values, Y values. Y'all have seen plenty of tables that kind of look like those. What we want to focus on always to start with are our inputs. So that'd be the X values. When you see something that looks like this, where all of the X values are different, which is what we got right here, right? We got a different X value on everything. 100% for sure whether it works or not, we're going to go ahead and say that it works the way they end up working out these types of problems. So if all the x's are different, it is a function. Where it gets a little different is when we get a repeating x value. So you can see we got a -1 and a -1, right? That would be like we hit the same button twice. The first time, we got a -9. Second time, we got a 2. So is this one working correctly? No. That's like if you push the button for Dr. Pepper, you get Dr. Pepper the first time, you push it again, you get a Pepsi, right? Not working. So not a function. If we see repeating x's, in most cases, that's going to mean not a function. I said in most cases, though. We got repeating x's here, right? Numbers repeating. So the first time I hit that -1, I'm getting a -9. If I get a -1 again, I get a -9 again. Well, that means it works, right? We're pushing the same button more than once and getting the same thing. So that's the one exception on the repeating x's, okay? In most cases, probably like 90% of the time or more with problems, if you just look at the x values and whether they repeat or not, that's going to mean it is a function or not a function, okay? If all the x's are different, automatically it is a function. If the x's repeat, you got to check the y values to make sure they're either the same or different. If the y's are also repeating the same, that means it's okay. That means it's a function. If the x's and y's are like the x repeats with different y values, that's when it's not a function. Everybody kind of follow? All right, so sometimes you see weird tables that look like this. What we have is on the left side, those are our inputs, our x values. On the right side are my y values. So did x values repeat? No. If we got one arrow coming from each x value, that means it's not repeating. What about this one? Any of my x's repeating? No. So each of these are functions, okay? The x's aren't being used more than once. What about this one? Is this one a function? Yeah. Why? None of what? None of the x's repeat. We got a y value that's repeating. That 4 has 2 arrows pointing to it. Y values can repeat. That is okay. X values are the ones that cannot. Okay? Is this one a function? No, why not? X repeats. We've got 2 arrows coming from the X going to different Y values. Okay? So you see how these little, I don't even know what they're really called, circle chart things are a little bit different, but still work kind of similar to a table. Usually the X values wouldn't have that 2 even over there then. Okay? It's just if you see 2 arrows coming from the same input. What about this one? Is this one a function? Yeah, why? Yeah, our x value is repeating value each time, okay? There's 2 2s on the right side, so that one makes it okay. All right, any questions on those? If an x value repeats, it must have the same y values to be a function. Repeating x's with different y values means not a function. Sometimes we see ordered pairs. When you see an ordered pair, which letter comes first? X. It's X and then Y, right? So if we got X, we got Y, what we're looking for are X values, okay? So I got 1, 5, 8, 2, 3. Did any of those repeat? No. So that one is a function, okay? I got 3, 4, 5, 6, 7. Any of my x's repeat? No. So that one is a function. You see some of the numbers repeat, like we got 3s and 4s and 5s and 6s and 7s, and it doesn't follow the pattern it started off with, but that part doesn't matter for right now, okay? So that's not a function. Or sorry, is a function. My fault. We got 7, 3, 6, 3, 2. Is that one a function? No, why not? X repeats, and then even more so, we got to look at the Y value just to make sure it does not, okay? If both of those were 3, 4, then it would be okay. All right? Everybody with me on that? So we have to be able to tell if graphs are functions or not also. So this line here, we're going to tell if it's, or be able to tell if it's a function or not, okay? The way we do that is by what is called the vertical line test. Vertical is horizontal, like the horizon, left to right, vertical, up and down. So we're going to use a vertical line. Never has to really be like 100% perfectly straight or whatever, but it should be pretty close. One of the things that's easiest to use, even when you're on a laptop, need to. So the way the vertical line test works, you take your vertical line, and I'll use this so I get a nice straight one, and we slide it over the graph. You can see as I'm going over that green line, how many places are the red and green line intersecting? How many places do they intersect right now? 1. They're intersecting right there. All right. When two lines intersect, it's where they cross. Anywhere I move it, anywhere that vertical line goes, the green line and the red line are only crossing one spot. What that means is if it's only crossing one spot, it is a function. Okay? So we look at this one here. Vertical line. How many places is it crossing? It's only crossing at one spot. So when it only crosses at one spot, that means it is a function. How many spots is this one crossing? 2. So we have a point of intersection at 2 different spots. When the lines intersect at more than 1, usually you only see 2, but it could technically be more than 2, means it is not a point of intersection makes it not a function. Whether that one's a function or not. Kari? It is a function. If we draw our vertical line, just like on the ones before, anywhere that it crosses, it's only crossing at one point. Okay?